Hey everybody, it's Merm here. Today we are going to do a lesson on entropy. This is our last lesson of Unit 8, our study of kinetics. So if you go open up the PowerPoint, and I want you to look carefully at each of these sets of images. And in the box on the next slide, I want you to write what you notice about each. So like here's one image, here's another, so there's 5 of them on this page and 3 of them on this page. And then this is the box where I want you to write in what they have in common. What is it about these images? All right, so take a minute, pause the video and do that. All right, so now you're back to the video, which means you have looked at all of those diagrams and noticed or drawings or pictures and seen what's different at the beginning and the end. So our new word today is entropy. So the word entropy means the amount of disorder in a system. So just like all those pictures, there was part of the picture that showed a lot of order and part that showed a lot of disorder. So entropy means the amount of disorder that you see in a system. So now I want you to think of it in terms of phases of matter. So if this is a solid and this is a liquid and this is a gas, when you draw a solid, you draw all the molecules nice and close and orderly. And a liquid, you have them start moving apart a little bit. And a gas, they're much more random and all over the place. So as you go from a solid to a liquid to a gas, entropy increases because there's more disorder. Here, your molecules are all over the place, so there's increased disorder. Here, it's very orderly. They are all in order. All right. What about aqueous? Where would aqueous fit into this order? So if I know as I go from solid to liquid to gas, where should I fit it in? I know as I go across, entropy is increasing. So first of all, let's think about what aqueous means. So aqueous is a mixture, and it means that it is mixed well with water. So let's do NaClAq. That would mean I have salt dissolved in this water. So it is not a solid. It's not as organized as a solid. It's not as organized as a liquid because I have these particles mixed into the liquid. And it's not as disorganized as a gas, so it belongs right in this area. AQ would go between these two. Because it is a mixture, it does have more disorder than a pure liquid. So I'm going to write that right here. More disorder than a pure liquid. So if I just had H2O, that is pure liquid, but if I add salt to it, I now have more disorder. So I have a greater amount of entropy than I do a liquid, but not as much as a gas. All right, so let's go through and start doing our predictions about what's happening to entropy in each of these physical reactions. So if I go from a gas to a liquid, I'm becoming more organized, so my entropy will decrease. If I go from a solid to a gas, I'm going to have way more entropy, so entropy will increase. I will be more disordered. If I go from an aqueous to a solid, that means I got to take out the water. And so making it be a solid is definitely making it more orderly. So that would be a decrease in entropy, much less disorder. And if I start with a solid and I add water in and I break it into aqueous, I'm becoming more disorganized. So my entropy is increasing. So you'll see with each one, I had to ask myself, entropy is the amount of disorder. I had to ask myself that every time. Now let's think about chemical reactions. When you think of a chemical reaction, do you think what has more entropy, individual atoms or a compound? So when you look at this first picture, here are my individual atoms. I have Cl, so I'm just going to write it over here. I have Mg, and that's a +2. And then I have Cl, which is a -1. And I had to crisscross to get MgCl2. And the reason why was Mg had 2 valence electrons to give away. So it gave 1 to this Cl and 1 to this Cl. So that's why you need 2 chlorines to satisfy 1 magnesium. And now here is my compound MgCl2. This is much more stable. So my entropy is decreasing when I change from these elements to a compound. So my individual atoms have more entropy, more disorder, and a compound has less entropy, less disorder. Or you can look down here at this picture. See these individual atoms, and now they are forming these compounds. Compounds are definitely more organized. So that means they have less disorder, less entropy. And each of these atoms are all on their own individually, so this has more entropy. And you always have to be comparing something. So it's like this versus this, or this versus this. All right, basic rules for predicting if entropy is going to increase or decrease. Number 1, if you are changing phase, if you go from a solid to a liquid, or an aqueous, or a gas, entropy increases. Things become more disorderly. Or our other rule is if you form a compound, or I'm just going to write, if you bring atoms together, you will decrease entropy. You'll decrease the disorder. So let's do some more practice. So let's look at this reaction. I have N2 and I have O2, and they're coming together to make this substance. If I look at the phase of matter, they're all gases, but I'm taking atoms and I'm forming a compound. So my entropy is definitely going to decrease. My entropy will decrease because I formed a compound. The compound is more orderly than the elements. The next one, I have 4 of these and 3 of these coming together to make 2. So even just looking at the numbers alone, starting off with 7 different reactants and I'm making 2. That is definitely more orderly. So I am decreasing my entropy because I am doing 2 things. I am forming a compound and I am reducing the number of molecules. All right, how about this one? I start off with carbon dioxide and I do decomposition and I break it back down into carbon and oxygen. When I do that, I'm breaking it apart, therefore I'm making it more disordered. So my entropy increases. Anytime you do decomposition and you are breaking something apart, you are making it more disorganized. So you're increasing the entropy. All right, let's look at this one. I start with glucose, C6H12O6, and I add oxygen. So this is like cellular respiration, what you do. And you change that, you combust into carbon dioxide and water. So this process If I just look at like, well, I have 2 things on the left and 2 things on the right, that's not enough to look at. So at least I should count them up. So 1 of these and 6 of these is I have 7 reactants over here, and over here I have 12. I have more. So I am increasing my entropy because I am breaking down the glucose into more molecules. So if I break it down into more, I'm increasing the disorder, so I'm increasing the entropy. All right, so what tends to happen in nature? I always tell people, think of like what's happening to your room. So like how messy is your room? Rooms tend to get more messy. So entropy over time tends to increase. And then think about yourself. By the end of the day, do you have more energy or less energy? Systems tend to go towards having less energy. So by the end of the day, you get tired and your room gets messy. Funny to think of it in terms of you, but it works the exact same way with most systems in nature. Things don't tend to get organized, they tend to get disorganized. Things don't tend to get more energy, they tend to lose energy. All right, so here is one that I want you to practice. So I am going to be grading these last few slides. So this slide is all about predicting the changes in entropy. Is it increasing or decreasing? And then you got to give me a reason why. And then the last few slides are some review. So what I have done here is I have built in a little bit of entropy, but a lot of basic chemistry review. So I want you to go through these 3 slides and answer all the questions, draw out the Lewis dot diagrams, figure out the moles, any of those things. And then the last slide that I want you to do is I want you to tell me 3 old things in chemistry that you feel like, you know what, every time this comes up, I always need some help with it. So what things do you want us to review that you feel like you never really understood that well? All right, have a great rest of your day. Bye, guys.